Okay, hi everyone, welcome back to this video series on Windows Server 2016. Direct access servers get one or two more NICs. One big question that needs to be answered even prior to installing the remote access role onto your new server. How many NICs are needed on this server? There are two supported methods for implementing direct access single mode. Your direct access server can be installed with only a single NIC. In this case, you would typically plug that network connection directly into your internal network so that it had access to all of the internal resources that the client computers are going to need to contact during the user's DA sessions. In order to get that traffic from the internet to your direct access server, you would need to establish a network address translation, NAT, from a public IP address into whatever internal IP you have assigned to the DA server. Many network security administrators do not like this method because it means creating a NAT that brings traffic straight into the corporate network without flowing through any kind of a DMZ. I can tell you from my experience that single NIC mode does not always work properly. It does a fine job for spinning up a quick test lab or proof of concept, but I have seen too many problems in the field with people trying to run production direct access environments on a single NIC. The ability to use only a single network card is something that was added onto direct access in more recent versions. So it was not originally designed to run like this. Therefore, I strongly recommend that for your production DA install, you do it right. You do it the right way and go with edge mode with two NICs. Here we have two network cards in the direct access server. The internal NIC typically gets plugged right into the corporate network, and the external NIC's physical placement can vary depending on the organization. We will discuss the pros and cons for where to place the external NIC immediately following this section of our chapter. Edge mode with two NICs is the way that direct access works best. As you will remember from earlier in this book, implementing a Windows server with multiple NICs means that you will be multi-homing this server and you will need to set up the network settings accordingly. With a remote access server, your external NIC is always the one that receives the default gateway settings, so you need to make sure and follow this rule and do not configure a default gateway on the internal NIC. On the other hand, you do want to configure DNS server addresses into the internal NIC properties, but you do not want to configure DNS servers for the external NIC. Since this server is multi-home, you will likely need to create some route statements in order to add your corporate subnets into the Windows routing table of this server before it is able to successfully send and receive traffic. The only networks that would not need to communicate for adding static routes would be small networks, where all of your internal devices were on a single subnet. If this is the case, then you have no need to input static routes, but most corporate networks span multiple subnets, and in this case you should refer back to the section where we discussed multi-homing and how to build out those route statements. More than two NICs. Nope, don't go there. If you are familiar with configuring routers or firewalls, you know that you have the potential to install many different NICs on this server and plug them all into different subnets. While there are many reasons While splitting up network access like this on a remote access server might be beneficial, it won't work how you want it to. The direct access configuration itself is only capable for managing two different network interfaces. As you can see in the following screenshot, during the setup wizards, you will have to define one NIC as external and the other as internal. Any more NICs that exist in that server will not be used by DirectAccess, unfortunately. Maybe this is something that can change in future versions. To NAT or not to NAT. Now that you have decided to roll with two NICs in your DirectAccess server, where do we plug in the external? There are two common places that this external network interface can be connected to, but depending on which you choose, the outcome of your DirectAccess environment can be vastly different. Before we talk about the actual placement of the NIC, I would like to define a couple of protocols that are important to understand because they pertain very much to answering this question about NIC placement. When your DirectAccess laptop makes a connection to the DirectAccess server, it'll be doing so using one of these three IPv6 transition tunneling protocols. These protocols are 6-4, Teredo, and IP HTTPS. When the DA client connects its DA tunnels, it will automatically choose which of these protocols is best to use, depending on the user's current internet connection. All three of these protocols perform the same function for a DirectAccess connection. Their job is to take the IPv6 packet stream coming out of the laptop and encapsulate it inside IPv4 so that the traffic can make its way successfully across the IPv4 internet. When the packets get to the DirectAccess server, they are decapped so that the DA server can process these IPv6 packets 6-4. DA clients will only attempt to connect using 6-4 when the remote laptop has a true public IP address. This hardly ever happens these days with the shortage of available IPv4 addresses, and so 6-4 is typically not used by any DirectAccess client computers. In fact, it can present its own set of challenges when users are connecting with cell phone cards on their laptops. And so it is common practice to disable the 6-4 adapter on the client computers as a DirectAccess best practice setting, Teredo. When DA clients are connected to the internet using a private IP address, such as behind a home router or a public Wi-Fi router, they will attempt to connect using the Teredo protocol. Teredo uses a UDP stream to encapsulate these packets, and so as long as the user's internet connection allows outbound UDP 3544, Teredo will generally connect, and the best transition protocol of choice for the DirectAccess connection, IP HTTPS. If Teredo fails to connect, such as in the case where the user is sitting in a network that blocks outbound UDP, then the DirectAccess connection will fall back to using IP HTTPS, pronounced IP over HTTPS. This protocol encapsulates the IPv6 packets inside IPv4 headers, but then wrap that up inside an HTTP header and encrypts it with TLS SSL before sending the packet out over the internet. This effectively makes the DirectAccess connection an SSL stream, just like when you browse an HTTPS website. Installing on the true edge on the internet. When you plug your direct access server's external NIC directly into the internet, you grant yourself the ability to push true public IP addresses on that NIC. In doing this, you enable all three of the above transition tunneling protocols so that direct access client computers can choose between them for the best form of connectivity. When installing in the True Edge method, you would put not only one but two public IP addresses on that external NIC. Make sure that the public IP addresses are concurrent, and as this is a requirement for Teredo. When your direct access server has two concurrent public IP addresses assigned to the external NIC, it will enable the Teredo protocol to be available for connections. Installing behind a NAT, it is much more common for the networking team to want to place the external NIC of your direct access server behind a firewall inside a DMZ. This typically means creating a NAT in order to bring this traffic into the server. While this is entirely possible and better protects the direct access server itself from the internet, it does come with a big downside. When you install a DA server behind a NAT, Teredo no longer works. In fact, the direct access configuration wizards will recognize when you have a private IP address listed on the external NIC, and it will not even turn on Teredo. When Teredo is not available, all of your direct access clients will connect using IP HTTPS. So why does this even matter if Teredo is unavailable? Because it is a more efficient protocol than IP HTTPS. When Teredo tunnels packets, it is simply encapsulating IPv6 inside IPv4. The direct access traffic stream is already and always IPsec encrypted, so there is no need for the Teredo tunnel to be doing any additional encryption. On the other hand, when IP HTTPS tunnels packets, it takes the already encrypted IPsec traffic stream and encrypts it a second time using SSL. This means all of the packets that are coming and going are being subject to additional processing and CPU cycles, and it makes for a slower connection. It also creates additional hardware load on the direct access server itself, because it is now handling double the encryption processing. This is a particularly apparent problem when you are running Windows 7 on the client computers, as the double encryption process will make a noticeably slower connection for the users. Direct access still works fine, but if you set a Teredo connected laptop next to an IP HTTPS connected laptop, you will notice the speed difference between the two. In Windows 8 and Windows 10, there have been some countermeasures added to help with this speed discrepancy. These newer client operating systems are now smart enough that they can negotiate the SSL part of the IP HTTPS tunnel by using the null encryption algorithm, meaning that IP HTTPS is not doing a second encryption and the performance is much more on par with Teredo. However, this only works for the newer client operating systems, and it still doesn't work in some cases. For example, when you enable your direct access server to also provide VPN connectivity, or if you choose to employ a one-time password OTP system alongside direct access, then the null algorithm will be disabled because it is a security risk in these situations. So even when your Windows 8 and Windows 10 computers will be doing the double encryption when they connect via IP HTTPS. You can see where it will be beneficial to have Teredo enabled and available so that any computers that can connect via Teredo will do so. To summarize, you can certainly install your DirectAccess server's external NIC behind a NAT, but be aware that all of the DA client computers will be connecting using the IP HTTPS protocol, and it is important to understand the side effects of implementing in this way. Network location server. This major component is a DirectAccess infrastructure, is something that does not even exist on the DA server itself, or at least it shouldn't if you're setting things up properly. The network location server, NLS, is simply a website that is running inside the corporate network. This website does not need to be available for access over the internet. In fact, it should not be. NLS is used as part of the inside-outside detection mechanism on the DirectAccess client computers. Every time a DA client gets a network connection, it starts looking for the NLS website. If it can see the website, then it knows that you are inside the corporate network and the direct access is not required, so it turns itself off. However, if your NLS website cannot be contacted, it means you are outside of the corporate network, and the DirectAccess components will start turning themselves on. This prerequisite is easily met. All you need to do is spin up a VPN, a VM, and install IIS on it to host this new website, or you can even add a new website onto an existing web server in your network. There are only two things to watch out for when setting up your NLS website. The first thing is that it must be an HTTPS site, and so it requires an SSL certificate. We will discuss the certificates used in DA, including this one, in our next section of this chapter. In addition to making sure that this website is successful via HTTPS, you must also make sure that the DNS name you are using in order to contact this website is unique. You want to do this because whatever name you choose for the NLS website, that name will not be resolvable when the client computers are outside of the corporate network. This is by design because you obviously don't want your DA clients to be able to successfully contact the NLS website when they are working properly, as they would turn off their DirectAccess connection. The reason I bring up the unique DNS name is that I often see new DirectAccess admins utilize an existing internal website as their NLS website. For example, if you have a HTTPS intranet running as a SharePoint site, you could simply use this in the DA config as the NLS server definition. However, once you set it up this way, you will quickly realize that nobody who is working remotely can access the HTTPS intranet website. This is by design because the DA environment now considers your intranet website to be the NLS server, and you cannot resolve it while you are mobile. The solution to this problem: make sure that you choose a new DNS name to use for this NLS website. Something like https nls.contoso.local is appropriate. The most important part about the network location server that I want to stress is that you should absolutely implement this website on a server in your network that is not the DirectAccess server itself. When you are running through the DA config wizards, you will see on the screen where we define NLS and that it is recommended to do this, but it also gives you the option to self-host the NLS website right on the DirectAccess server itself. There are many things that can go wrong when you co-host NLS on the DA server, so stay away from doing that. Running NLS on your DA server also limits your direct access potential in the future because some of the advanced DA configurations require you to remove NLS from the DA server anyway, so you might as well do it correctly the first time you set it up. Changing your NLS website after you're running DA in production can be very tricky and often goes sideways. Here is a screenshot of the section in the DA config wizards where you choose the location of NLS and make sure you stick with the top box. Certificates used with DirectAccess. Aside from reading and misunderstanding about how DirectAccess uses IPv6, here is the next biggest turnoff for administrators who are interested in giving DirectAccess a try. Once you start to read about how DA works, you will quickly come to realize that certificates are required in a few different places. It is hard to distinguish which certificates go to where you are wading through TechNet. So this section is to clear up any confusion that exists surrounding DirectAccess certificates. It really is not very complicated. Once you know what does and does not need to be done, the core prerequisite is that you have a Windows CA server somewhere in your network. The stature of your PKI implementations is not that important to DirectAccess. We simply need the ability to issue certificates to our DA server and clients. There are only 3 places that certificates are used in DirectAccess, and 2 of them are SSL certificates. SSL certificate on the NLS web server. As mentioned just a few minutes ago, your NLS website needs to be running HTTPS. This means that you will require an SSL certificate to be installed on the server that is hosting your NLS website. Assuming that you have an internal CA server, this certificate can be easily acquired from that internal CA, so there are no costs associated with this cert. You do not need to purchase one from a public CA because this certificate is only going to be accessed and verified from your domain joined machines. The DirectAccess clients, since domain joined computers automatically trust the CA servers in your network. This certificate can simply be issued from your internal CA and will do exactly what we need it to do for the purposes of DirectAccess SSL certificate on the DirectAccess server. An SSL certificate is also required to be installed on the DirectAccess server itself, but this one should be purchased from your public certification authority. This certificate will be used to validate the IP HTTPS traffic streams coming in from the client computers because that is SSL traffic, and so we need an SSL certificate to validate it. Since the IP HTTPS listener is facing the public internet, it is definitely recommended that you use a certificate from a public CA rather than trying to use a cert from your internal PKI. Machine certificates on the DA server and all DA clients. The last and most complicated part of the DirectAccess certificate puzzle in the machine certificates is the machine certificate, sorry. Once you know what is required, though, it's really not hard at all. We simply require that a computer or machine certificate be installed on the DirectAccess server, as well as each of the DirectAccess client machines. This machine certificate is used as part of the authentication process for IPsec tunnels. It is a big part of the way that DirectAccess verifies that you really are who you say you are when your computer makes that DA connection happen. There is a built-in template on a Windows CA server called Computer, and this template does exactly what we need it to do for DirectAccess. So oftentimes we simply set up a policy to issue computer certificates to all of the DA machines. If you do not want to use that pre-built template for some reason, you can certainly create your own custom certificate template for this purpose. When setting up your own certificate template, just make sure that it meets the following criteria. The common name subject of the certificate should match the FQDN of the computer. The subject alternative name SAN of the certificate should equal the DNS name of the computer. The certificate should serve the intended purposes, enhanced key usage of both client authentication and server authentication. I should note here, though I don't really want to, that issuing these certificates is not absolutely necessary to make DirectAccess work. If you are running Windows 8 or higher on the client side, then it is possible to get DA working without machine certificates. They can instead utilize something called Kerberos proxy for their computer authentication when the IPsec tunnels are being built. But I highly recommend sticking with certificates. Using certificates as part of the authentication process makes the connection more stable and more secure. Additionally, like with the placement of NLS, if you want to do any of the advanced functions with DirectAccess, like load balancing or multi-site, or even if you simply want to make some Windows 7 computers connect through DA, then you would be required to issue certificates anyway. So just stick with the best practice in the first place and issue these certificates before you even get started with testing DirectAccess. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.